Hi, this is Tony Malik, Senior Product Manager for Windows Azure. In this walkthrough, I'll demonstrate how to set up the Windows Azure cache to cache reference data from a SQL Azure database. If you're not yet familiar with caching or need some background on the Windows Azure cache, please see the Windows Azure cache video available on Codeplex. The Windows Azure cache provides a simple way to hold your data in memory and close to your cloud-based applications. In a traditional solution, developers need to understand where cache data should reside, configure the environment, provision the cache, and then manage the data. With the Windows Azure cache, the complex mechanics, building, configuring, and managing the cache are pretty much all done for you, leaving you to focus on determining which data is suitable for caching and making this happen through the simple cache API or via configuration. So let's now do a demo. I'll show you how easy it is to use the Azure cache to cache data from a SQL Azure database. For this example, I am going to retrieve data from a SQL Azure database into a web page. Then we'll provision and enable the Windows Azure cache so that the data that was previously retrieved from the database is now retrieved by the web application from the cache. This provides both performance benefits and scale as load is taken off the database. Last, I'll demonstrate how to enable the local cache for even better performance. You can download the solution files, instructions, and a sample access database from Codeplex and follow along if you'd like. Okay, let's start. So I'll open and run the application for you first. Remember, this is a simple web page that gets data from a SQL Azure database. There's no cache in place right now. The project consists of a web role that queries data from a SQL Azure database. This application has a timer attached to the page load function that starts when the page begins to render and stops when it's complete. This timer enables us to compare the performance between retrieving data directly from the database or from the default and local caches. Better to show you rather than tell you, I'll run the application now. You see a table populated from a SQL Azure query. We've returned 2 columns and about 2,300 rows of data. I'm refreshing the browser a few times to establish a reasonable baseline. Remember, every user of this application is hitting the database every time the page is requested, so performance will get worse as the number of users grow. We now need to provision the Windows Azure cache. From the Windows Azure portal, create a unique service namespace for your cache. Select the basic properties and click on OK. Now provisioned, you can see the information we will need, the namespace, service URL, and the authentication token. Alright, now to the code. I'll do a brief walkthrough of the beginning state, and then we'll modify the code to enable the cache. Looking at the payload section, you see I initialize a local variable based on a class I added to handle getting the data from SQL Azure. Let's look at that class first. The class is called Airport List, and it makes the connection to the database, passes in the query, and then serializes the results so they can be used with the cache later. It returns the serialized airport data in an object called Airports. Back up to page load, you can see my request for this data passing in my connection string and the SQL query. The serialized results return and I bind them to the grid view control. To use this cache in our application, we need to wire it up now. In the Windows Azure portal, I click the View Client Configuration button in the ribbon, which exposes the service-specific configuration information we will put in our web config file. For this demo, we only need the config sections and data cache client sections. So I'm going to copy those and append them to the configuration section of the web.config file. After copying these sections to the clipboard, I'll go back to Visual Studio. Open web.config and paste the configuration data from the client configuration. Then to use the cache in the application, we need to add 2 more assemblies, the Microsoft.ApplicationServer.Caching.Client DLL and the Microsoft Application Server.Caching.Core DLL. You'll find them under Program Files in the Windows Azure SDK folder. With those 2 assemblies in the project, I'm ready to add the code to use the cache. Let's go to the code behind page of the default.aspx page and wire it up. To save some time, I'm pasting in a version of the code that enables caching, replacing the non-cached version. Note that the code in the airport list class remains completely unchanged. Okay, with that in there, let's walk through it. Right above page load, I've added the reference that lets me create a cache factory to use the cache. In page load, I set my airports object to null, declare and create a local variable for the cache object. Next, I check the cache to see if the data is already in the cache. If the cache is empty, I make the same call I made in the non-cached version to query the database and return the serialized list. Once I get the data, I populate the cache and set an ASP label so we can echo to the page. As before, I set the grid view data source to the airports object and do a data bind to populate it. Let's run this. The first time this runs, the cache will be empty, so we'll see slightly longer results as our earlier test, as the code is populating, then reading from the default cache. Subsequent page refreshes show us the application is using the default cache, saving a round trip to the database and reducing page rendering time. Remember, this performance will also stay relatively constant as concurrent users increase while I'm using the cache. Without the cache, the database will start to saturate and performance will get increasingly worse as load increases. Now I'll show you how to enable the local cache, which will improve performance even more. The local cache is local to the web role, getting your non-volatile reference data even closer to your application. We enable the local cache in web.config. I've saved a little snippet of XML that I'll paste into the data cache client section. Be sure to place it just below the hosts tag and save web.config. Alright, with this change, let's run the application again. After a few page refreshes, you'll see the performance improves even more, as the web server doesn't need to go across the network to the cache to get the data. It can now get it from the same machine. Page render has dropped significantly faster than from the database and faster from the cache tier. In this presentation, we've done a few things. We connected to a SQL Azure database for a baseline. We set up and provisioned the default cache. We wired up the cache to our application and noted the performance benefits. We then configured the application to use the local cache and noted we got even better performance in our application. I hope you see how easy this is and the benefits it can provide to your application. I recommend you test this out yourself and find out how simple the service is to set up. The demo code, scripts, and snippets are all available on Codeplex. Please go to windowsazure.com where you can find the latest information and additional resources to help you try this out for yourself. Additionally, you can find details of our current offers, including a free trial, and download the SDK. Many thanks for your time.